On this fifth video lecture, we'd like to talk about objects. That is to say that Python data structures are not just stable entities. They're just not inert and sit there. That they actually know things and that they can do things. And so understanding that Python data really is an object and the implications about that, a really crucial step to learning Python. Let's get started. Also suggested, one of the big steps in leveling up our Python skills is understanding that data in a Python program is not just a kind of inert, lifeless pile of stuff. Data in a Python program actually has behaviors and actions, and that's because in Python, data is really an object. So let's take a look at objects, see what they are, and we'll understand how to use data and how to manipulate data better in a program. Now, if you've ever done any object-oriented programming before, this is going to make some sense. You know what an object is. An object, in computer programming terms, is a data structure that both knows things and does things. So it has behaviors, it has actions. It doesn't just reflect back to us what we put into a bucket or a list, but that we can actually tell the list or the bucket to do certain kinds of things. You can think about those actions as verbs. And in fact, I'll think about them grammatically as verbs as we go through because, hey, who doesn't like a grammatical metaphor, right? They're always appropriate. So these actions or behaviors are technically called methods. And we'll review that more a little bit later when we get to functions as well. But for some stupid reason, I think of objects a bit like the Death Star in Star Wars. They're two halves united. The top half is all business. You know, it does some stuff. It can shoot. It does all of that. The bottom half is just full of databases and data and people who are analyzing stuff, right? And so I don't know why I think about objects as kind of a three-dimensional representation of the Death Star, but you can think of them however you want to. Let's take a little bit closer look here. If we imagine a string, if we imagine that string as an object, that string both has data, it knows what it is. Let's imagine the string ABCDE. I put that into a bucket. That is the thing that the string knows. It knows what it is, but it also does some things. I can ask it to convert itself to lowercase. Well, this one already is. I could convert it to uppercase. I could tell it, believe it or not, this sounds worse than it is. I could tell it to strip. Strip just means that I'm going to take any blank spaces from the beginning or the end and get rid of them. It's a really crucial step in data cleaning, and we'll see that later. We saw in one of the earlier videos that I used split, which takes a string and divides it into words. It splits it at the spaces. We could do the reverse. We could join it together. I can even ask questions of the string because it knows something about itself. So I can say, hey, string ABCDE, do you start with the letter, say capital R? And the answer is no, I don't, so that's false. I could say, hey, string, do you end with the letter lowercase e? Well, in this case, that's true. So the string knows certain things about itself, and I can ask it questions. Same with a list. We've already seen some of these, right? We played with a list a little bit earlier, and we did append, which adds new elements. We popped, which takes elements off. We told a list to sort itself. There are all kinds of other things, too. I can ask it, what is the index of a particular value, right? What is the index of the value A in that list? And I will get back 0 because it's the 0th element. I can tell a list to reverse itself. I can remove elements at any time. So a list knows how to manipulate itself in certain ways, and that's really important. And of course, we know a dictionary is also an object. We could look at the keys, we could look at the values, we could look at the items. Those are things a dictionary knows how to do. And I've added a new one here that we haven't seen yet, but that we'll see in an upcoming video. This is the file object. This is a thing that gets created when we bring data into a Python program from some external source. Like maybe we're loading something out of a spreadsheet, or we're loading the complete works of Shakespeare. So to do that, we will create a file object, and you can see that we've got read commands and write commands. A read command brings data into a program from an external source. Write takes data from a Python program and pushes it out to that external source. So the reason I wanted to show this to you is because I want you to start thinking about objects. I want you to start seeing the things in a Python program as an object. That means that it knows things and does things. And when we start to understand that Python loves objects, puts objects everywhere, our lives are going to get a little bit better. But it does mean, too, that we have to kind of level up a little bit so that we understand Python better. If you've come from object-oriented coding, this is going to make a lot of sense. But if you haven't, this division of two parts is really a division between data and behaviors. So in object-oriented coding, all of that data, believe it or not, inside an object are other variables. And I'm sorry if that seems like it's going to suddenly turtles all the way down. But if an object is a two-part data structure, one of those parts are little tiny variables, little buckets, little dictionaries, little lists that can hold things. And sometimes in object-oriented coding, we'll call them properties or attributes. And really, they're just the things that the object knows. If we want to stick with that grammatical metaphor, and who doesn't? These are really kind of like nouns and adjectives, right? Like, what is the nounness of this string? Well, it's that sequence of characters A, B, C, D, E, right? But those actions or behaviors are more like verbs because they're things that happen or questions that are asked and answered. Behaviors that are undertaken. They're much, much more like verbs. So if we start to think about objects in Python as having these two components, like a kind of data component that, I'm going to say it is kind of inert and stable and just kind of stays the same, but it's complemented by these actions or behaviors that are called methods. That's the crucial part that we need to remember for Python. Let's take a look at a string here. So here I've just taken a bucket called city and I'm putting into it the string Edmonton. So I can call a ton of these methods on that particular string. So you can see on the left here the methods that I'm calling. You can see on the right the result of that. So I can convert it to uppercase. I can convert it all to lowercase. I can ask, do you start with a capital E? Yes, I do. Do I end with an R? Nope, I don't. I can replace all the O's with X's. I can figure out where in that string is the first occurrence of the letter M. It is in the tooth drawer. So find and index get me to the same place in that regard. But if I ask at the end of all of those processes, what is in the bucket called city, it's still Edmonton. And that's because, as we have seen, strings are immutable. And by the way, you can see this here in the text, but every time I execute one of these behaviors or I tell the object to perform that behavior, we say that I'm calling the method. So if I say call the upper method or call a replace method or something like that, that means just to invoke it or to make that behavior happen by really, literally, by saying its name. Right? One of the questions we've had is why Python made the choice to make strings immutable. And there are actually a couple of good reasons for this. One is simply that speed. Python strings are faster if Python knows that they can't change. One of the other big reasons, though, why strings are immutable is because of the prominence of dictionaries in Python. They're really, really commonly used. If a string could change at any time, that means that dictionaries would need to update themselves constantly in the event that strings changed. So if the string is immutable, that makes dictionaries as a data structure more stable because you don't have these kind of cascading updates. And so same with the inner parts of the string. There are things that the string knows about itself. This might be a little less onerous that the internal parts of a string object would need to update themselves. But again, it's a kind of a cascading data thing. As soon as one part of the data structure changes, then other parts have to change, and that might even implicate or have consequences for other external data structures. And that gets to be really complicated. So Python has simplified this by making strings immutable. One of the things that I was reading was that we should actually change the way that we think about strings, that we should think about them as being as elemental and primitive and basic and in some sense atomic as a number. So if I have the number 5, it's always the number 5. But if I change it in any way, shape, or form, say just by adding 1, 5 hasn't changed. 5 is still 5. It's that I get a new number now, which is 6, and 6 is different. So one of the pieces of advice that I've been reading is that we should start to think about strings as being elemental and primitive in the same way that we think about numbers. Maybe that's helpful. Here's a cool trick that we can do with methods. We're going to play with this a ton, and we're going to see this a lot as we go forward, but I want to show it to you now. It's one of the things that makes Python really, really powerful, and it's called chaining. And I got to admit, I love chaining. I love languages that chain. So here's a bucket. Again, I just put the word Edmonton into it, and now you'll notice what I'm doing. I can do several activities to that string all at once just by listing them in a row. So the first thing I'm doing, reading left to right, is I'm replacing every O in the string Edmonton with an X. And once that behavior, once that action, once that operation is finished, now I'm swapping the case. So everything that was uppercase becomes lowercase, and vice versa. Everything that was lowercase becomes uppercase. And then, after that, I'm doing this funky thing called a right justification. So I'm saying I want a window of 15 characters, but I'd like you to put this string on the right-hand side and just fill in with blank spaces on the left-hand side, as many as you need to make up a length of 15 characters. And you can see the result here. There's a single quotation mark hanging a little bit over to the left there, and a bunch of spaces, and then you can see the result of Edmonton, which is just a ridiculous string now at this point. And again, just to repeat, the bucket called city has not changed, and that's because strings are immutable. So no matter what kinds of changes I go through, the bucket called city still contains the original string, unchanged. Here are two things that we would normally play with if we were doing this in class, but I just wanted to put these on a slide so that you can see what's happening. Every string has this interesting method called join. What it does is it joins together elements in a list. So here are a list of names, some guys in a band. Who knows who these are? I just made these up. And then you'll notice I have a string here called glue. Glue is a comma followed by a blank space. And I'm using glue as a way to join together every element in that list of names. And so now you'll see I get John, comma, space, Paul, comma, space, Ringo, comma, space, George. So the glue makes one string out of everything in that list. Every string has this join method, and so I could actually concatenate together really interesting strings out of lists just by changing whatever glue happens to be. This is a really handy one. Here's one at the bottom that we'll see a ton when we get to data cleaning. That strings can contain these sort of funky meta characters like tabs or a new line. A new line is actually the character that you get when you hit return or enter on your keyboard. Now, most of the time those are invisible. We can't actually see them. If you go into your text editor, we were playing with this a little bit in one of the labs one day, that if you turn on the invisibles in your text editor, you can start to see them. Inside a string in Python, we can put tabs and we can put new lines, but they get these meta character symbols of \t and \n. The backslash takes what we would think of as a mere mortal character, a T or an N, and it turns it into a special character, kind of a superhero character. So if you look here, I've got a dirty string, and there's a single quotation mark, the \t, which is a tab, followed by \n, which is a new line. That's like enter or return, followed by a couple of spaces, and then the word hello, a couple of spaces, and then a new line at the end. And we'll play with this in the terminal window. You can print this out. Python will actually respect the tabs and respect the new lines when you print it out. But if we're importing that data, and this is something that we want to work on for maybe, say, text analysis, or we're doing word frequency counts or whatever, those white space characters of tabs and new lines and spaces are just getting in our way, and we'd like to get rid of them. So every string has this method called strip, and what strip does is it takes off all the white space characters in the front and in the back. And you'll see what I'm left with. I'm just left with the clean string hello with all of that extra gunk removed. So cleaning data is a really big process in digital humanities, and this strip method for strings is one of the things that we're going to use. There are other tools that we'll see as we go further along. Regular expressions, for example, we'll have a whole lecture on those later. These are crucial tools, really important tools that we can use when we're doing data cleaning. Lists 2, objects. We've seen this before. So here on the left are a series of methods. On the right are what would happen to that list after I call that method. So if I start with the list CBA and I append the letter D, D goes onto the end. I can insert into the tooth drawer the letter E, and you'll see on the right what the result of that is. And then I can sort my list, I can pop my list, I can ask which index the letter B happens to have, that is in the 1th drawer, reverse the list, remove a C no matter where it is, or I can even extend it. And extend is a way that I can combine 2 lists together. So it's a little more sophisticated than append. So if I have the list DBA and I extend it with the new list EF, you can see that they combine into one list. And again, remember, lists are mutable. Dictionaries are mutable too, and we've already seen a lot of the methods that we can use when we're working with dictionaries. So I can ask for the keys or the values or the items, and you'll see that all of those things work here. Dictionaries have a get method, so that says go into the dictionary in the drawer called age and bring me back the value. Get is a little more sophisticated than this, and we might see this in the future, because if the drawer called age does not exist, I can tell get what to do in that event. So I'm kind of preventing some access errors there. Dictionaries don't really have an append or an extend. Dictionaries are a little easier to work with. If I wanted to create a new drawer with the label home and put the word London into it, all I have to do is create it just like this. And you'll see on the right-hand side there the resulting list that I would get. And the star there, yeah, you can remember those things are tuples, right? So if I ask for the items, I get a list of tuples back. And again, now maybe it starts to make perhaps a little bit more sense, right? If those things are tuples, they're not changeable. And so I can't go in and change those tuples because it does not then cascade back into the dictionary called person. So by changing the things in items, which I'm not allowed to do because they're tuples, if I could change the things in items, Python would have a decision to make. Should I change the original dictionary or should I not? Python solves that problem for us by making those into tuples, so I can't. Yeah. All right. You all already have noticed that the dot is a really crucial part about how I call or access these methods. The dot is called the accessor symbol, and it's used all the time in Python, and we're going to see in the future more ways in which Python uses the accessor symbol. Any of those of you who've worked in an object-oriented language have seen this a ton. The dot or the period is a really common one. Other languages use other ones, like PHP, for example, uses a small arrow. You have to type 2 keys to get it. But no matter what the accessor symbol is in that language, it works the same way. So I use a dot to tell Python to access a method that exists on an object. So if my list is ABCDE and I want to append, or ABCD, I want to append something, then I can use the dot append. The dot isn't optional there. The dot needs to be there because it says on that object there exists a method called append, and I want you to go perform that method. So that one is pretty crucial. On the right is another way that we'll see the accessor symbol that we haven't quite gotten to yet. These are called modules, and we're going to have a whole lecture on modules. But for now, you can think of a module as an external library of code. Python has literally thousands of these. There's so many of them. It's a really crucial aspect about Python. It's a really important thing that we need to wrap our head around, and we'll do that in the future. But for now, just say, okay, there's an external library called random. There are all kinds of random number things in there that I can do. Here, I'm simulating rolling 2 dice. And I'm doing 1 die. Remember, the singular is die, the plural is dice. So I'm rolling 2 die. And what I'm saying is, in that external library of random, there is a behavior or a function called random integer, randomint. And I want you to give me a random integer between 1 and 6 because I'm simulating the roll of a 6-sided die. And I'm doing that twice, and I'm just adding them up, and that's my roll. Could be part of a game, for example. We might use random numbers if we're doing a simulation, like some sort of baseball simulation. Who knows? But what's crucial here is that the dot is the thing that's important, right? The dot is not only the accessor symbol for objects, but it's also the accessor symbol for these external libraries, which we will call modules. You can start to see that Python is very, very consistent about its syntax. Once Python figures out how to say something, it says it very consistently. So if I'm looking inside an object for a method, or I'm looking inside a module for a function, or some data inside a module, I use the accessor symbol. It's very, very consistent. We'll start to see it all the time, all over the place. A couple of screenshots here before we go and play in the terminal window. Here's a terminal session that I've done before. You can see what I'm doing in the Python interpreter up at the top. I've created a variable called x, and I put the integer 4 in there. When I ask Python what the type of x is, you'll see I get class int. It's an integer, obviously. We already know now that x is an object. And Python has a function called dir for directory that lets me look inside that variable to see what's there. So if I do a directory on x, you'll see that I get a list of all kinds of things, square bracket list. For example, that first one is underscore underscore abs underscore underscore. And then down at the end, there are some things that don't have underscores. These are all the methods and some of the data things that are inside an integer. These underscore underscore ones, or what we would call a double underscore, these are called magic methods. Python even calls them dunders for double underscore. So these are dunders, and you'll notice there are a ton of dunders. Dunders get called in a magical way. And so, for example, here's one, underscore underscore add underscore underscore. That is a method in an integer object that gets called whenever that object is involved in an operation that uses the plus sign. And down here, there's dunder sub, which gets called whenever an integer object is involved in a minus operation. And so the objects themselves are somewhat transparent in that we can look inside them and we can see all of the kinds of things that are in there. You'll notice there's a lot of these. Here's a double underscore equal. That gets called whenever an integer object is involved in a Boolean test of equals equals. Or look at these, right? Greater than equal to, greater than, less than equal to. Anytime an integer object is involved in some of these symbols in the yellow, what happens is that a method gets called on that integer object, and these dunders are the methods that get executed. Now, we're probably not going to go this term very far down the rabbit hole, down the path of object-oriented coding, but if we were, we could create our own new objects, and we could create our own dunder methods. So this is a transparent part of how objects work in Python, that if we were to create our own objects, we could start to take advantage of this. When we get to the terminal window right now, we'll play with that a little bit with a string, but we'll do a couple of other things. So let's just jump into the terminal window. All right, well, here we are in the terminal window, and I'll just jump into the Python interpreter again. Let's just do a little experimenting with some of the object strings and things like that. So I've just taken the liberty already to copy something, and I'm going to paste it in here into the terminal window. So you'll notice that this is a literal string. Bob and Doug went to Edmonton. It's not in a variable. It's a literal string. But because it is a string, Python knows that it will have certain kinds of attributes, certain kinds of methods, certain kinds of behaviors. So well, the first thing I'm going to do is I'm going to take that string and I'm going to convert it to lowercase, and then I'm going to split it. Now, split will divide that string wherever there is a space. So I'm just going to get some words on the other end, and I'm going to put that into a bucket called tokens. And if I look at what tokens is, there you go. Bob and Doug went to Edmonton. It's just the words themselves, and they're all lowercased. This is really important for text analysis because, as we've seen, uppercase letters and lowercase letters are not treated by Python the same. So is a lowercase b the same as an uppercase b? No, they're not the same at all. So this is one of the ways that we can do text analysis. And as you can see, using this idea of chaining, I can actually do tons and tons of work on a string all in one fell swoop without having to do that step by step by step. All right, here's another one. I jumped out for a minute so that I can type this mess. I paste it. This is an absolute disaster. Greeting is a whole list of tabs and some new lines and some spaces and a tab and space and new line, etc., etc., etc. Python is perfectly happy to accept that. And if I ask what greeting is, you'll notice that it gives me back a format that looks a lot like what I put in. But if I print greeting, I'm actually going to get something really different. And you'll notice here now that Python respects those new lines and it respects those tabs. So I get a couple of blank lines, and hello is tabbed in a little bit, and that's all because of those spaces, the new lines. It respects all of that. But if I'm doing some text analysis or I'm processing this in some way, all of that white space, those tabs, those new lines are really going to bother me. So I can put this into maybe a new string, and I'm just going to take greeting, and all I want to do is strip it. And clean is really simple. It cleans off all of that extra nonsense. And again, this is going to be really important for us when we're working with data. And always assume, anytime we bring data in from some third party, that it is not clean, and we will write some Python code to do some cleaning of that on our own. Now, if I look at what's in some string, like let's take clean for an example, here is the inside, the inner workings, the inner guts, if you want to, about what that string is. And you'll see all kinds of dunders here. And let's just ignore those for the moment. What I see at the end is all of these other things down here at the end of that list. And capitalize and case fold and center and count, ends with, right? Is decimal, is digit, right? All of those is methods, you can almost guess those are Boolean methods. Like, is this thing a decimal? Is this thing a digit? Yes or no, true or false, right? You can see there's join, our old friend join in there. There's a bunch of strips. I can strip it on both sides, or I can join and strip on the left or on the right. I can split it. I can do all kinds of things. Does it start with this? These are all of the methods that belong to that string that I am allowed to use. So I can go into greeting and I can say, is greeting is a decimal? False. Greeting is not a decimal. Is greeting is ASCII? True. ASCII, I'll let you look that one up on Google. It's the American Symbolic Code for Information Interchange. It just means that is it alphanumeric in a way that makes sense. And it is. That's absolutely true. I can do, let's see, what is greeting? I don't even remember. Let's see. There's that. Oh, it's clean. Hello. So if I say, hey, I want clean, lower. There you go. It's all lowercase. No. Completely fine. Two things quickly before we go, and then I'll encourage you to play with these to your heart's content. I'm going to create a new set out of the letters in the word banana. Now, set is a verb or an action. It's going to take whatever I send it, in this case a string, and it's going to turn it into a set. It builds a set out of that thing. But you'll notice that set does not belong to an object. It is free-floating. It is unaffiliated. And so these are functions. We're gonna spend 3 lectures on functions in the future. So, but it's not affiliated with a particular kind of object. It is it's a mercenary unto itself. It can do anything it wants to. So it's a free-floating function. What it returns to me, I'm going to put into the variable here called letters. And if I look to see what letters is, there it is. It's the 3 letters B and N and A. So it has removed all the duplicates from the word banana, and it is curly brackets without key value pairs. So therefore, I know it's a set. If you remember, a set is an unordered collection of elements with no duplicates. That's the definition of a set. So if I try to sort a set, I can't spell sort, but if I try to sort a set, by definition, I can't do that. So I should get an error message. And in fact, I do. Here it is. This set object has no attribute sort. You notice this is an attribute error. Remember, those components, the principles, the parts of an object sometimes are called attributes. And so this is an attribute error. But if I don't trust Python, like, Python, I just don't trust you right now. I want to take a look instead inside in here and see what I can find. I can do a directory on letters. And if I skip past all of the dunders and I look down here at the bottom, these are the methods that I can call on a set object. And you'll notice there are some pretty setty things I can do, right? I can find the intersection. I can find the union. I can add 2 sets together. I can ask questions like, are these 2 sets disjoint, or is this set a superset of that set? All kinds of funky things like that. So this is the way that I can double check, or if I'm just confused, not double check, I'm not really, Python's correct always, but I can, if I'm confused, like I thought there was something I could do in there about sorting or something. What does that mean? I can do the directory and find out. If I want to know more about what these are, I can actually also ask for help. So I can say, hey, I would like some help. I have this data structure called letters, and I want to know what difference is. What does it mean to do a difference on a set? So I can type help, and then in brackets letters, and then difference, and I will get this. Difference is a method of built-in sets, and it returns the difference of 2 or more sets as a new set. That is to say, it gives me all the elements that are in this set, but not in the other ones, right? And that's kind of handy. Now, I think at the Macintosh terminal window, I get this as I have here in a new screen, and you can see it's blinking end here. I need to push the Q key to quit to get out of that. I think on maybe the Anaconda one on Windows, it just puts it in the same terminal window. I don't know. But if you get some of these with, it kind of clears the screen a little bit and it puts it up, just hit the Q key on your keyboard and then that will dump you back out again. Let's look at one more of those before I go. I'm just going to do one on a string. We've already looked at split. So let me get some help on string split. Now, it knows that str is a data type here, so I don't even have a variable, but If you had a variable, you could just put that in there too. So I'm just going to ask for help. What is a string split? Please tell me more about that. I'd like some documentation on it, please. Here you go. So split, there's some stuff up here, split, and it takes some interesting parameters which we've never put in there. It returns a list of the words in the string using what would go into this variable SEP, the separator, as a delimiter. And SEP is the thing on which we split a string. The default value is white space. So if there's any tabs, new lines, spaces, that's where split separates its stuff. And in fact, there's even another parameter there that I can tell it how many splits to do. The default value is -1, which means it will split everything forever, world without end. And that's totally, obviously totally fine. So I can get some more information about things. Now, we haven't really used functions and parameters and all of those sorts of things yet. But if I had a string like, what am I? Oh, let's just do banana. Because there's a lot of A's in there. I want to split that, but I want to split it on the A character instead of the space. Then I get B and N and nothing. I get actually a zero-length string at the end. But this is how I can look inside an object to find out more about what the methods are inside that object. And even here in the Python interpreter, I can get more information, more documentation about it by asking for help. Is all of that help stuff available on the web? It sure is. And in fact, there's some more details on the web, but we'll look at that a little bit in the future. All right, well, that's it for objects, methods. I know this got to be a little bit long, but again, this is one of the really, really foundational, important components about Python. And to get better at Python, we really have to appreciate and start to learn how to use objects in the way that Python intends. All right, thanks.